All right, here are your notes 6.4. I think in my fourth or fifth period, I said 6.3, but this is actually 6.4 notes. Objectives, be able to perform basic operations with two separate functions. So basic operations meaning adding, subtracting, multiplying, or dividing. You're going to take one function and then do the operation with another function, and you're going to come up with a brand new function. Sometimes in books they call it a new rule. And once we have that new function, I want you guys to state the domain of it. So, a little bit of connection to prior knowledge here. Operations with expressions. Now, we've done this before where we had one expression. So this is a binomial. Here's a trinomial. So we did different things with these. First thing we learned was how to add them. Okay, so basically you took them out of their groups and then added their like terms. And then we learned how to subtract them, how to multiply them, how to divide them, things like that. So we actually did all of these with two different expressions already. Now the only new thing today is that we're going to actually put it in function notation. So it's not going to look like this right away. The first thing that we're going to see is this whole f of x function notation and g of x. So you're going to have to know how to replace those. All right, so domain, couple things here. Basically, inputs and outputs, domains are your inputs that you can put into your function that make it work, quote unquote. Two main things that we're looking for restrictions on our domain. So we're going to figure that our domain is all real numbers. So we're not dealing with complex numbers right now, but our domain exists in the real number realm. And then what's going to happen is we'll have all these choices from the real numbers, and then slowly we'll be able to kind of take some of those choices away. So you're not going to be able to plug in any real number on some of these. So the main things that we're going to be looking out for, at least for right now, are dividing by zero, because dividing by zero is a no-no in math. It does not exist. And looking out for even roots of negative numbers, or if you have a rational exponent, then even denominators. Basically, because if you take an even root of a negative number, then you will end up in the complex, and we don't want complex numbers right now, we just want real numbers. So these three examples we had in class. First one is 3x over 2x minus 8. Now, two things you're looking for, dividing or even roots. This one has division, so you should start, your like little red flag in your mind should come up and say, uh-oh, something might happen. Right here we have a even root, so same thing, same little warning sign in your brain should say, okay, hold on, there might be a restriction on the domain. This one has neither. It does not have dividing, it does not have an even root. So if you don't have either of those situations happening, basically that means that you're able to plug in or put as your input any number you want. And if you think about it, you can square any rational number and it's fine. There's no rules being broken or anything. So let's start off with this one. Since this one does not meet any of the requirements, then your domain, this is notation that you can write it in. Domain is all real numbers. Okay? And that's it. There are different ways of writing out your domain. That's the way that I'm going to show you guys. Your teachers in the future might show you a different way that they might want to see it, but that's the way I want to see it. So we're just looking for domains here. So this is an expression. This is a fraction. So one thing we don't want is a 0 in the denominator. So here's my denominator. My denominator is this entire thing. So if I'm not saying that I don't want x to be 0. What I'm saying is I don't want the bottom to be 0. So the bottom's 2x minus 8. So the thing is here, so 2x minus 8 should not be 0. Okay, that's what we're trying to figure out. Okay, is that I don't want that to be 0. So in order to figure out what, because we're going to solve for x, because that will tell me what would make this 0. Now in your head, you could actually think about this right now. X can't be a 4, because 2 times 4 is 8. 8 minus 8 is 0. So my x cannot be a 4. Now the way you set it up is actually like this. Actually set up the equation. Solve it out. You get 2x can't be 8, and then x can't be 4. So right now, you're allowed to plug in whatever number you want into the x value, that's a real number, and it'll work. 2 times 1, 2 times 5, 2 times 7, and then subtract 8. And you'll get different numbers on the bottom. The only number you're not allowed to have is a 0, and we just figured out what x value would make that happen. It's going to be a 4. So the way you would write your domain is, your domain is all real numbers. This is a symbol for all real numbers, except x cannot be 4. So what this is saying is your input, which you're allowed to put into the function, is every single number that exists in the real realm except for 4. That's it. Okay. So when you have a denominator, that's the way you do it. Is set it up so it's not equal to 0, then solve out. This one is an even root. We're not supposed to take even roots of negatives because it'll end up in the complex um, number realm. So what we're going to do is we're going to take this expression, x minus 8, and we need to think of a way to say, okay, we want that to be non-negative. The only numbers that are non-negative are 0 and bigger, because any number bigger than 0 is positive, which is non-negative. So we want this to be bigger than 0, and it can also be equal to 0, because you can take a square root, cube root, fourth root, all the even roots of zeros are fine. Okay, so the first thing is you want to look for this little 6 right there, make sure it's even, because that's the only thing that would cause a problem. So even roots and denominators. Solve this out, x is greater than or equal to 0. So your domain here is any number that's bigger than or equal to 0. I'm sorry, not 0, that's wrong. We're adding 8. So there you go, 8. So any number that's bigger than or equal to 8 will give a nice, neat, positive number inside of here. Okay, so when you're stating your domain, you say my domain is, and don't put all real numbers because this actually tells you what your domain's allowed to be. Your inputs are allowed to be any x value that is bigger than or equal to 8. So that is your domain. So that's how you find domains. We hadn't really focused too much on it in class, but this is basically how you find out what you're allowed to plug into your functions. All right, so let's get to this. Add and subtract the following functions, then find the domain of the new resulting function. So we got two functions here. We got a 2x minus an 8 and a 3x squared minus 7x plus 10. So what we're going to do is, actually, hold on. I'm going to split these up so it's easier for me to work with. All right, so first example, we're going to add, so f of x is equal to 2x minus 8, so that's my first function. Second function is g of x equals this trinomial right here. So the first thing is I'm going to add f of x to g of x. So f of x is equal to this. So what we can do is we can actually substitute in here. So think about what f of x actually is. So what's going to happen is we're going to have an f of x, then we're going to add it to the g of x. All right? But we are going to be substituting in. So what is f of x? F of x is 2x minus 8. So I'm going to take this f of x, 2x minus 8, that just goes inside of there. That's what I did, I broke it apart. Ha ha ha. Wait a minute. Let's make this out a little. And g of x. What is g of x? G of x is this thing. So I'm going to take this thing and put it inside of there. Let's make it fit inside of there. Okay. So just like I showed you before with these expressions, now you would just do like how I was explaining over here. Okay. This is connected to operational expressions. So in order to add these two groups is that we have to first get rid of the parentheses. You do that by distributing a 1. That'll break it up into smaller parts. So 2x minus 8 plus 3x squared minus 7x plus 10. Combine your like terms. 3x squared is just a 3x squared. Negative 7x combines with a 2x minus 5x. And negative 8 and a positive 10 is positive 2. So that is my new function when I add my f of x to my g of x function. Now the next thing is state your domain. So your domain is, so my domain, keep in mind you're looking for two things, division and even roots. There is no division and there are no roots here to be even anyways. Second power is not a root, that's an exponent. So domain is all real numbers. Okay, that's how you do that. Next part. G of x minus f of x. So what we're going to do is we're going to take g of x minus f of x. All right. Now g of x, so let's put these back where I got them. This is up here, this is right here. So f of x is 2x minus 8. So make sure you put them in the right spots. F of x is this one, g of x is this one. And that's not going to fit. Let's move that over. There you go. Okay, g of x is this one, because that was up here. And f of x is this one. So now this one's a little bit different because you have to be careful when you distribute. When you distribute the first one, it's just going to be 3x squared minus 7x plus a 10. The other one is a negative 1. So when you distribute the negative one, make sure you switch both the signs. So negative 2x and positive 8. Now you combine like terms. So 3x squared, that's gone. 7, negative 9x. and 10 plus 8 is an 18. That is your new function. Now your new function needs a domain, so you know what you can plug in and what you can't. So your domain is also all real numbers, once again, because there is no division going on, so there's no way to divide by 0, and there is no even roots going on, so basically you're allowed to plug in whatever you want for your x's. Your inputs can be whatever. All right? So example 1 is done. Speed it up a little bit. F of x plus g of x. So f of x is 2x. So same thing as before, just substitute in. Only difference now is that it looks a little bit more complex with the rational exponents. But your f of x is 2x to the 1/2 plus your g of x, which is negative 6x to the 1/2. We don't need any parentheses because these are just one term anyways. Looking at this, like this looks like the last section. Last section we learned about like terms. Those two are like terms, which means that all you're focusing on is the 2 and the negative 6. 2 minus 6 is a negative 4, and then x to the 1/2 power. Now, for that's simplified, we combined all the like terms that we could. For our domain, your domain you need to figure out, is there any even roots? Now, this might be in a form where you're not used to, so you can rewrite it as 4 times the square root of x. Now, we just said that we're not supposed to have an even root. So we want the stuff on the inside of the root to be bigger than or equal to 0. And there's no solving involved, so that's it. Your x's have to be bigger than or equal to 0. So x's have to be bigger than or equal to 0. Another way you could state that is your domain is all non-negative real numbers, which means the same thing. There's different ways of stating it. Basically, you just have to make it clear to me that you know what you're allowed to plug in. This one, g of x minus f of x, same type of deal. Negative 6x to the 1/2 minus f of x, which is 2x to the 1/2. Focus in on the like terms. So you can do negative 6 minus 2 is a negative 8x to the 1/2. And that's the same thing as negative 8 square root of x. Restriction here, x has to be bigger than or equal to 0. So this is my simplified form, and my domain is all my x values that are bigger than or equal to 0. Okay, so basically when you have a root, you set the inside bigger than or equal to 0 when you have an even root. When you have a denominator, you set the bottom not equal to 0. Okay, those are your two situations that may happen. This is very similar to the last one we just did. The notation's a little different. If you notice, it says f of x plus g of x. This just says f or g plus f. Same thing though. It means the exact same thing as before. This is just a different notation that you might see it in. I'll just do the first one in order to save some time here. So g of x, the g function is 7/6 root of x plus your f function is 4/6 root of x. This is a like term, which means we can put them together. 7 plus 4 is 11. 6 root of x. So that's our simplified form. It is an even root. Since it's an even root, to find your domain, you set the inside greater than or equal to 0 and solve. No solving required though, because basically it's already solved for x. There you go. F minus g, just switch them around. You should get negative 3 because basically you're just flipping them around. Negative 3, 6 root of x. Same domain. All right, so let's get to this, multiplying and dividing. So g of x times f of x. So what we're going to do is we're going to take the g of x function, which is x squared. So x squared. And we're going to multiply it to 2x plus 10. We only got one term here. We got a binomial here. So what we're going to do is basically just distribute because it's multiplying. You can do the box method too if you still feel comfortable with that. So x squared times 2x is a 2x cubed. X squared times 10 is a 10x squared. That's it. These are not like terms, can't put them together. Next thing is check for your domain. There is no dividing, there are no even roots, so your domain is all real numbers. Remember, that's what you're checking for each time you find your thing. Now, right now, I'm already spotting we have division, which means that we might be able to divide by 0. So what we've got to start thinking about is um, we are going to have a domain restriction on this one. So right now, g of x over f of x means that you have an x squared over 2x plus 10. For now, we're just going to leave it like this. So that's it. You could write this in different ways, but I want you to leave it like this for right now, okay? So we leave it like that. The main thing I want to get at here is your domain restriction. So right now it's not all real numbers. Right now I have a denominator, and that denominator, 2x plus 10, is not supposed to be 0. That entire thing cannot be 0, otherwise you're dividing by a 0. So now you got to solve it. So you got 2x is not going to be negative 10. So x is not going to be a negative 5. And double check that. If I put a negative 5 in here, 2 times negative 5 is a negative 10, plus 10 is a 0. So that is what is going to mess things up. That's why your x is not supposed to be that. So your domain is going to be all real numbers with the exception of negative 5. Okay? Like I said, there are other ways you might see this. I'll show you guys probably tomorrow the other ways you can see the notation here. And last one, I think. Nope, one more after this. So let's try multiplying these. 3x and x to the 1/4. So f of x is a 3x times g of x is only one term. I'm not going to use parentheses here since they're both just one term. X to the 1/4. I don't need to put them in a group when there's only one thing here. So 3x times x to the 1/4 power. Find the product and quotient. Okay, so it doesn't say what form we have to have this in. So what we could do here is basically just put these together. Since it's an exponential form, let's keep it in exponential form. This is to the first power. So what you do when you have the same base, you're supposed to use the product of powers, which means you're supposed to add those. So 1/4 plus 1 is 3x to the 4/4, 5/4 power. All right, so that is that. Now, if you think about this, we have an even denominator, which means that's a fourth root. So think about a fourth root x to the 5th power, but the main thing is that we have that x in there. This means that your domain will have a restriction. X's should be bigger than or equal to 0. No solving required because there's basically nothing to solve for. So domain is x is bigger than or equal to 0. All right, next one. So since these are in rational exponent form, I'm going to keep them in rational exponent form. So f of x is a 3x. G of x is x to the 1/4. Got to do a fancy one here. So what would I add to 1/4 in order to get 4/4? X to the 3/4. So there's my fancy one. 3/4 plus 1/4 is 4/4. So that's just going to be a regular old x. You'll have 4 over 4. But remember, 4 over 4 is just a 1. So you don't even have to put that 4/4. So let me take those off. So once again, this is x to the 4/4, which is 1. So this is a 1. That's 5/4, so 3x to the 5/4. Wait, oh, that's not right. That's 4. That's 7/4. There you go. Because this one will be a 4/4 in order to add 3/4. But you know what? There is a better way to kind of think about that. So whoopsie. Before we put these together, let's think about this. This is 3x to the 1st power times x to the 3/4 power. So now that I'm spotting this, this x to the 1st, x to the 1st, those will go away. So this will just be 3x to the 3/4 power. So sometimes it's better to kind of keep them separate before putting them together. Even root again. So when you have an even root, it should be x's are bigger than or equal to 0. That's your domain. And that's it. Okay, last example. A little bit different here. So let's try this. Different notation, f times g. So my f function is 4x to the 1/3 times my g function is, oops, I was going to write a g, x to the 1/2. So what you're going to do here is just add your exponents. So it's 4x 1/3 plus 1/2. You need common denominators, so 1/3, that's going to be a 6. So 2/6. That's just going to be a 6, so 3/6. So 3 plus 2 is a 5/6. All right. Even denominator, because you're going to have a 6 root x of 5. Take that inside part, set it greater than or equal to 0. So my domain here is x is greater than or equal to 0. All right, and last one. So g is x to the 1/2 power. F is 4x to the 1/3 power. Since I have the same base here and here, what I can do is just equal to 4 stays on the bottom, x to the 1/2 minus 1/3, the quotient of powers property. So what that's going to be is 1/2 is 3/6. 1/3, 6 is 2/6. Make sure that's right. 2, 3, okay. 3 minus 2 is a 1. So x is to the 1/6 power over 4. There you go. Once again, we have an even root here. So your domain is going to be x's are greater than or equal to 0. All right, so that's it. So tomorrow we're going to go into one more thing called composition of functions. Bring me any questions about these examples that you have. I'm going to come around and check these as your homework, so I should see 6 examples on your page. All right, have a good evening, night, / whenever you're watching this. Okay, bye-bye.